Kinematics is the study of motion without concern for what is causing that motion. Before we can talk about what's causing that motion, and ultimately how we can change that motion, we first have to be able to describe that motion. So let's jump right in. Let's say I were to ask you, how far away does Grandma live? Now, implicit within that question is how far does Grandma live from here? I could have easily been asking you, how far away does Grandma live from your house, from our present location, or even from school? Each answer that you would give me would be a correct answer, even though all of those answers would be different. Additionally, we can make some pretty big mistakes if I was asking you about how far away is Grandma from here, and you were talking about how far away was Grandma from your particular house. This leads to the important idea of establishing what is referred to as a frame of reference. A frame of reference is going to begin with an origin. The origin is simply where the frame of reference starts. So if we're talking about how far away is Grandma, our origin would be how far away is Grandma from where? Is it from your present location? Is it from your house? Is it from school? Wherever, that would be where the origin of your frame of reference is. After establishing an origin, we have to have an orientation. Let's say we're talking about north, south, east, and west. Again, things would be very, very confusing unless we have a mutually agreed upon direction of east. And for our purposes, we are going to end up always labeling that particular orientation so that we know which dimension it is that we're talking about. Finally, we have to have a sense. And when we're talking about sense, it's probably best described with an illustration. Let's say that we have a certain orientation and we mark 2 points on that orientation, point A and point B. Going from point A to point B would be one sense, while going from point B to point A would be the opposite sense. Now, when we combine these two things together, orientation and sense, we end up getting a direction. So again, we say that direction is going to include both the orientation as well as the sense. So now that we've established a frame of reference, we can say how far away is Grandma, and we can say Grandma is going to be 3 miles away from my house, which is the origin, east, which would be our direction. Now, west would have that same orientation, but it would have a different sense. And that will become more important when we start talking about movement that's occurring in 2 directions. Now, if we look at a CSUN map, we will see a CSUN map also represents a frame of reference. That frame of reference is going to start in the lower left-hand corner at the corner of Reseda Boulevard and Nordhoff. And something that will become more important when we start talking about movement in 2 dimensions, you see we have one orientation that goes east-west, and that is going to be depicted here by letters. And we have another orientation, which is going to go north-south, which is going to be depicted by numbers. So now that we've established our frame of reference, we can talk about a position. And a position is simply going to be a location within that frame of reference. Position is going to be abbreviated by the lowercase p. Now look at our frame of reference here. We have our origin, and we have a positive x direction. Now, any location that we have in that frame of reference is going to be our position. So our position is going to be where we're located at in our frame of reference with respect to our origin. And if we want to draw a position vector, that position vector will start at our origin and will go to our position. And note again that that's going to be depicted, in this case, by a straight arrow. And I hope you can appreciate that the further away we are from that origin, the longer that arrow is going to be. Now in biomechanics, we're just not interested in positions, but we want to know how things are changing. And so our next variable is going to be displacement. and displacement is simply going to be the change in position. So let's return back to our frame of reference here. And I guess I should first out by saying that we are going to be abbreviating displacement not with a D, but with a delta P. P stands for position. The delta, the Greek delta sign, stands for change in. So our displacement or change in position is going to be represented by the delta P. So if we have a certain position within our frame of reference, and then at another point in time, we have a different position. Remember that other point in time is going to be represented by that prime sign. Then we can simply draw a vector that's going to go from our initial position to our final position, and that will be our displacement vector. Mathematically speaking, we can say that delta P is simply going to be that final position minus the initial position. Displacement is a vector. Remember, vectors have both magnitude as well as direction, and that displacement is simply going to be the change in position. That is going to be different than the total distance that's traveled. Let's say that I'm located at the corner of Reseda and Nordhoff, and I have to get back to my office in Redwood Hall. Now, there are several different routes I can potentially take to get there. One route, I can travel down Nordhoff until I get to East University Drive and then cut up to get to Redwood Hall. In another case, I could actually cut through campus and potentially several buildings in order to get to that same final position. Note in this example here that there was two different routes that I took to get from my initial position to my final position. And as I'm sure you are all aware, the shortest distance between 2 points is a straight line, so that second route will end up being shorter than that first route. However, when we're talking about displacements and we're just talking about change in position, we are talking about simply subtracting the final position from that initial position. And so if we're only traveling in a straight line, that distance and displacement are going to end up being the same. As soon as we start curving or changing our particular directions, distance and displacement may not be the same. So here we've introduced frames of reference, position, and displacement. Now it's time to move on to velocities.